Welcome to This Explainer. Today, we're tackling one of the absolute biggest bottlenecks for anyone building multi-step AI systems right now, and that is cost. Our goal today is ambitious, but I promise you it's totally achievable. We're going to explore how to radically cut your AI workflow costs without losing a single ounce of quality. We are talking about true builder-grade optimization. Now, if you're running what we'd call a naive AI strategy, meaning, you're just sending every single prompt to the biggest, most expensive frontier model available, well, you're probably just barely breaking even. But there's a specific routing pattern that delivers massive ROI, dropping your costs by a factor of 3 to 30. We're literally talking about taking a $3,000 monthly AI bill and dropping it down to just $300. Multiplied across a year, that is the cost of a junior engineer saved simply by changing how you map your tasks. Okay. Let's dive into this playbook. Here's our roadmap. We'll start with the AI cost asymmetry, hit the cheap workhorse pattern, break down bulk versus polish work, look at the actual cost math, and finally, cover when this pattern actually breaks. Section 1, the AI cost asymmetry. To really get this, we kind of need to flip our standard mental models on their head. We usually treat every single AI task as if it's equally difficult, right? But this quote really captures the reality of the asymmetry. Most steps in your pipeline are actually incredibly easy. They don't need the massive reasoning power of a frontier model. They just need a competent one. Only a very select few tasks genuinely require those expensive, heavy-hitting capabilities. Recognizing this heavily skewed difficulty distribution, that is the secret to unlocking your profit margins. Section 2, the cheap workhorse pattern. So what exactly is the cheap workhorse pattern? Well, it's the practice of routing all your routine bulk work to cheap models and strictly reserving those expensive frontier models for the final polish. As we mentioned, this cuts costs dramatically, but here is the absolute crucial part. There is zero perceivable quality loss in the final output. Why? Because the user never actually sees the work of the cheap models. They only see that polished, high-quality, final result from the frontier model. Now, what's really interesting about this slide is how this maps to a real-world workflow, like customer feedback triage. Just look at the steps here. Classifying the sentiment? A cheap model can do that perfectly. Extracting the topic? Super easy. Deciding the urgency based on simple rules? Easy again. 3 out of the 4 steps here are incredibly cheap. It's only that final step, actually drafting a sensitive, on-brand customer response, that's hard and actually requires that frontier capability. Section 3, bulk versus polish work. Think about AI models like human workers for a second. You would never, ever pay your most expensive senior analyst to sit around all day doing a junior analyst's routine sorting work, right? It makes no sense. Well, the same exact logic applies to your AI system. Your junior analyst handles the bulk work, categorizing 90% of those routine, well-defined reports. Your senior analyst handles the polish work, stepping in to apply careful judgment to that ambiguous 10%. We have got to stop pricing all our cognitive work at senior analyst rates. So what goes into the bulk work bucket? These are tasks that reliably belong on competent, cheap models. Think Haiku 4.5, DeepSeek V3, or Gemini Flash. We're talking about things like classification, data extraction, and summarization. It also includes basic routing decisions, translation, and generating standardized content. The common thread for all of these? They all have well-defined right answers. The model isn't being asked to be deeply creative, it's just recognizing patterns and following strict rules. But then, on the flip side, we have polish work. This is where your frontier models, your Opus 4.7s or GPT 5.5s, actually earn their keep. We reserve these heavy hitters for final customer-facing outputs, nuanced multi-step reasoning, and high-stakes decisions where a wrong answer literally costs you money. This also covers sensitive creative output, like writing an apology to a user and handling weird, messy edge cases. These are the moments where tiny differences in quality compound, and the output is usually going straight to a human being. Section 4, calculating the cost, math. And this brilliantly illustrates exactly what we're talking about. Let's say you have a workflow classifying 1 million inbound emails a month. Pure, unadulterated bulk work. If you run that entire thing on Opus 4.7, it's going to cost you $625. But if you route it to Haiku 4.5, it drops to $125. Llama 70B brings it down to $92, and GPT 5.4 Nano, just $26. That is a staggering 24-fold cost difference for executing the exact same bulk task. To put that into perspective, the payoff here scales exponentially with volume. Now, if your workflow is mostly heavy polish, like, say, generating massive essays from tiny prompts, your savings are going to be modest, maybe 10 to 30%. But the reality, most builder workflows are high-volume classification and extraction. For those pipelines which are heavily skewed toward bulk work, this pattern acts as a massive multiplier, easily yielding 5 to 20 times the savings. Let's move to and see how this builds into a really common pipeline shape. We like to call it extract, then generate. Unstructured data flows in, and right away in step 1, the cheap model does the heavy lifting to extract and structure that data. Then, in step 2, the expensive frontier model simply takes that nice, clean data and applies the final, high-quality, customer-facing polish. It's an incredibly elegant 1-2 punch.
Section 5. When the pattern breaks. Okay, knowing when to use this pattern is fantastic, but knowing when not to use it, that's what makes you a true system architect. You've got to watch out for these 4 failure modes. First, a quality bottleneck. This is where the bulk step is actually just too complex for a cheap model to handle reliably. Second, garbage in, garbage out. A frontier model cannot magically fix corrupted data handed to it by a cheap model. Third, latency budgets. Stringing multiple model calls together adds time, which can ruin real-time interactive apps. And fourth, honestly, if your volume is so low that your monthly bill is under $30 anyway, it just isn't worth the engineering headache to set this all up.
So, to help you audit your own pipelines, here's a highly practical diagnostic checklist you can use before you write a single line of code. Just ask yourself, does this specific step's output go directly to a human user? If yes, lean toward a polish model. Does the step involve nuanced reasoning? Yes? Lean polish. Is it a well-defined classification or extraction task? Yes? Lean bulk. Just run this quick mental check on every single step individually. So what does this all mean for you? Well, I want to leave you with this provocative question. Are you pricing all your workflow tasks the exact same and just leaving piles of money on the table? It's time to rethink your architecture, folks. Stop the careless default model selection. Start mapping one specific model to one specific step based strictly on the difficulty of that task. Once you implement this cheap workhorse pattern, you're going to maximize your ROI, and honestly, you will never look at AI costs the same way again. Thanks for joining me on this explainer, and happy building.